Hello and welcome back to Get Kafka-Nated, the show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. I'm Hugh, your host, and I'm excited to be back with you today for another episode. Today we're diving into something that's increasingly critical for modern cloud operations, building real-time CDC. We're talking about processing cloud events on a huge scale, maintaining sub-second visibility, and doing it all cost-effectively. To that end, I'm delighted to be joined by Kyle McCullough, co-founder and CTO of OpsHelm. Welcome to the show, Kyle.
Hi, Hugh. Thanks for having me. Great to be here.
It's great to have you here, and yeah, really looking forward to this conversation today.
Yeah,
To
likewise.
get started, can you walk us through a bit about what OpsHelm is and what problems you guys solve for your customers?
Yeah, of course. So I'll give you the short version, and we can dig in if you'd like. But OpsHelm, in a sentence, is a real-time cloud intelligence and visibility platform. The way that we like to describe it via an analogy is it's kind of like the flight recorder on an aircraft. So think of the flight recorder constantly capturing all sorts of telemetry and information in real time and storing that and archiving it in case it needs to be analyzed later. So the OpsHelm platform does more or less the same thing for a cloud environment. We are capturing all sorts of information in an event-driven fashion. We are then normalizing that, enriching it with context, storing it for historical analysis, and then shipping it back to you in real time so that you can pump it into your own systems, analyze it, build alerting, whatever you need to do.
Amazing. I like that flight recorder analogy, like the mission critical and like that the level of granularity there. What prompted you to build OpsHelm on streaming infrastructure in the first place? Like, why not batch processing for these cloud events?
Yeah, of course. So I think anybody that is operating in the cloud is probably doing so for any number of reasons, but one is it's so flexible and you can deploy anything and change anything at a moment's notice. As your needs change, the cloud is there, it's elastic, it's flexible. And by the nature of being, that elastic and flexible and configurable, monitoring it and keeping track of your cloud footprint is that much more challenging, right? Scanning a cloud environment once a day or even once every few hours can tell you a lot about what's happening and what's changing in the cloud, but you really miss, any of those sort of ephemeral or intermittent changes that may happen between those scanning windows. So, batch processing is effective, but we think real-time processing is more effective because we can capture those configuration changes in the moment as they're happening and then make sure that they're available for you later to be able to understand what happened in between, these two time windows where I, have scanned and analyzed the state of my cloud. So being event driven is really key to being able to execute and deliver that promise.
So, if we start like digging into those events, what does that data kind of pipeline look like for capturing these cloud events and then bringing it into your sort of data layer? How are you ingesting events from these different clouds?
Yeah, it varies by cloud provider a little bit, but I think if you kind of stand back and squint a bit, it looks sort of the same through a fuzzy lens. And without getting into sort of cloud specifics, we are essentially hooking into whatever event capture and publishing system each of the cloud providers exposes to us. Uh, configuring it so that we can ingest events and audit logs through that real-time delivery system. And then once we get it into our system, we're leveraging our own technologies and choices within. So we're sort of at the mercy of the cloud providers for consuming the real-time events, whether it's EventBridge on AWS or the Pub Sub service on Google Cloud. We want to integrate as closely as possible so that we can get information as quickly as possible. But then once we've gotten it, we put it into our own systems and process it using our own methods.
So moving from that, like getting it out of the cloud providers, I definitely hear that of like being at the mercy of the way that cloud providers choose to do things is something that we've come across once or twice on this show. Um, I think it would be fair to say that you've had like an interesting technical journey when it comes to taking those events and streaming them, right? Once it comes to processing them on your side. Um, can you talk us through a little bit around some of the different things that you've tried for getting that performant and cost-effective streaming of all of these, very many events from all of these different platforms?
Yeah, of course. I think, I don't know if there are any founders listening, but I think every founder goes through this process of, oh, I'm starting a new thing. I have to choose a bunch of technologies. What are we going to build on? And, I, of course, looked at my background. What am I comfortable with? I think it's usually a pretty sensible choice, right? What do I know how to operate, and what do I know how to program against, and all of these things? And, I started with what I knew. So, um, I had been writing a bunch of Go in the past. We're integrating with clouds. So, of course, naturally, I gravitated towards that. Obviously, the fact that there are tons of tools and projects that are cloud focused written in Go as well was very nice. So we started there. My background as well also includes a lot of like data engineering and backend type work, as well as infrastructure work. So, we kind of started with Kafka in mind, because that was my background. I've been running it since it was just a LinkedIn open source project, and it was, pre 1.0, very early days. So I've been familiar with it for a long time. So we kind of started with MSK, and it seemed like a sensible choice. Of course, we'd considered, native cloud technologies as well, like Kinesis on AWS, for example. But we settled on MSK, and then, that's quite an expensive service as far as AWS services go. So I wasn't super thrilled to look at how much we were spending on that. And in looking at what we were, building and the Go ecosystem, we kind of shifted over towards Nats. And Nats is, for the uninitiated, Nats is a sort of messaging server written in Go. It's somewhat popular in the Go community, and it sort of exposes a number of different patterns to you as a consumer. So you can have, very work queue style methods of consuming data, or you can run it in a more Kafka style kind of distributed commit log sort of thing. We, of course, chose the latter, running it in kind of a Kafka style, since that's pretty close to what we needed, and something that was familiar and sort of second nature to me. We landed there and kind of stayed there for a long time for a number of reasons. One, the tooling in the Go ecosystem for Nats is quite good. Their libraries are, it is written in Go, so their libraries are quite good and very idiomatic, and it was a nice development experience. But the operational experience was less so, I'll say, and that has now driven us back to Kafka, and I'm happy to say that Ivan's timing with Inkless has been absolutely perfect, because we were ready for something new, but the idea of operating Kafka in kind of the traditional sense for our workload was not really all that appealing, and being able to use object storage as the back end and give us a lot of flexibility and much more elasticity really aligned with our needs quite nicely. So that's kind of been the journey. I'm happy to dig into
Of
any
course.
part of that if you'd like, but that
I,
brings us
I
to
think
today.
it's 100%. I think it's really interesting seeing that full picture, right? And it's like I definitely relate to that feeling of, you're like, right, I'm going to start with what I know, and then as we encounter these problems down the line, then we can start thinking about more specificity or more specialized tooling. Um, Coming right back to the beginning of that, and we will definitely be circling back to Diskless and Inkless later on. Um, when did you realize that MSK is this commodity Kafka, it's fairly dependable and fairly cheap? When did you realize that uh, wasn't going to be cost effective at the kind of scales you were working at?
Pretty early, I think. And to be honest, I mean, I felt similarly about Nats. I think the idea for our platform, having to run a cluster of servers with, disks and be monitoring our capacity and utilization of online storage, right? Doesn't really make sense for the way that our platform operates. We get lots of events in, we need to operate on them in a pretty short period of time, and then we want to kind of archive them. So, after an hour, let's say, the need to reconsume one of those events is, pretty rare. And at the same time, we still want to archive and have access to them. So, doing that on disks, attached to servers is like so not cost effective. And combine that with the fact that we're consuming events out of our customers' cloud environments. Cloud environments vary in size and activity level very wildly. So we're not really in control of the volume of data we're ingesting either. So that makes sort of the scaling and operation of those nodes pretty tricky. We have to keep a close eye on things. If a customer attaches an account that is generating much more data than any previous account we've seen, now suddenly our sort of scaling formula is a little broken. So we have to make adjustments, and having to do that is just a distraction for us, and it wasn't delivering value, and managing it is challenging, and it's a 24/7 job. Whereas from our perspective, object storage, hey, it's right there. It's effectively infinite as far as we're concerned, and it is a little bit more expensive if you think about it in terms of operations and things like that you're performing against the object storage. But the long tail data storage is much cheaper for us, and it's much more ergonomic for us in terms of being able to manage that data effectively without having to constantly be shuffling disks around and spinning up and down servers and all of that. So that whole set of problems kind of evaporated once we realized that we could do this a different way.
I can see why scaling would be such a headache with Kafka out of the box or MSK, of like needing to meet those SLAs for your clients, but working with a system that does not love adding or removing nodes in a performant way because of the need to rebalance partitions.
Yeah, of course, and that's I think that's just normal operational activities, but you take into account that sometimes servers fail, or all the other sorts of disks fail, all the other sorts of things that are not just normal operational exercises. And now you're dealing with, I have to recover data, and I have to do all of these other things to bring my cluster back up into a healthy state. Gets old very quickly.
Talking about the kind of operational headaches that sometimes come with running streaming at scale, the move to like NATs is really interesting for me. I think maybe like a lot of other people working in engineering, kind of engineering adjacent disciplines, I seem to find myself having kind of debates with friends sometimes about different approaches to doing things. I have a friend who's working on telemetry, doing something like wind farms, oil and gas, and he has a lot of good things to say about NATs. Like you, I think they're a Go shop, so that like tight coupling with the Go ecosystem is like a really strong selling point for them. But I think you mentioned that there were some like operational headaches with NATs for you guys. Can you walk us through a little bit about what the move to MSK to NATs was like, and what made NATs appealing on paper?
Yeah, so I mean, the move honestly was fairly straightforward. Architecturally, the way that we configured it, very similar to Kafka. We're publishing messages on one end of the architecture and consuming them on the other, and we've got all these services. And NATS has things that are similar to things like consumer groups, so we could spin up kind of distributed consumers and things like that. And it has streams, which sort of capture groups of messages in a logical sort of fashion. So there wasn't a whole lot of kind of adjusting to the mindset and writing the code. It's very mechanical and fairly straightforward. You can kind of squint and see the similarities. So that was pretty manageable. I think in terms of the appeal of NATs, aside from just being written in Go and kind of having what I consider to be a very nice, fairly idiomatic library for Go consumers. And they have, libraries in a variety of languages, but I was pleased to see how nice the Go version was. It really aligned with a lot of the best practices and idioms that you would find. But aside from that, operationally, it was supposed to be much simpler, right? We're not dealing with Zookeeper, which I know isn't as much of a thing anymore. But I'm thinking back to my prior Kafka days and thinking, oh man, I really don't want to have to run Zookeeper ever again. boy, that's annoying. But it's all comes in one package. You have one binary, and it has its orchestration and consensus stuff built right into the broker. So you don't really have to do any sort of management of any sort of external state or anything like that, which is great. So you just run the binary and you configure it to tell it where the other nodes are, and it'll find each other and create a cluster for you. And in my mind, I'm thinking, okay, this is so much simpler, right? Static binary, I just download it, have a cluster of servers, and everything is going to be so much simpler. It wasn't quite true. I think you are right. There's a lot of positive information that you'll find out on the internet about how robust NATS is. I think, in our case, part of the problem is maybe we were holding it wrong in a sense. NATS is quite happy when data moves through it very quickly. Anytime you have any sort of bottleneck, it gets pretty grumpy if there's a slow consumer or it's not able to flush data to disk. Not that I'm pointing any fingers at any particular hyperscaler for having maybe a less than reliable block storage system, but
naming no names.
Yeah, no names. But yeah, I think for us, the nature of running it, we just didn't quite fit the performance envelope that I think NATS really requires. So we had trouble with occasional slow consumers, or we're consuming cloud audit logs. Those messages can be quite large. I think NATS performs quite a bit better with many small messages as opposed to relatively fewer very large messages, and I think quite poorly if you have very, very many large messages. So it's we were kind of on the wrong side of things, as it were.
So coming out the other side of trying NATS, you're out here looking for Kafka compatibility. You've got these large messages, high volumes. I'm assuming also in there, like ordering is important because you've got this, the time. My brain is failing me here, but the timeliness of this data is important, and being able to do RCA from all these cloud events and stuff like that sort of requires that it comes in a specific order. So you have all of these workload characteristics, which then leads you to diskless Kafka. I think we've also mentioned as well, like being able to push stuff off to object storage and not keep it on local disk is huge for you guys, given the volume of the data and the kind of short window where you're interested in it. Why diskless, and why then inkless Kafka, which is to say the Ivan specific implementation of diskless Kafka?
Yeah, of course. So I'll answer the second part first. I think I've been kind of keeping an eye on this space for a while, and the reason for Ivan's implementation, the reason it's appealing to me, is Ivan is very focused on getting it into the upstream, open source Kafka, and Ivan has been incredibly transparent with the whole process and is really building a community around it. And that was very important to me, not choosing a vendor and a technology that would create a huge amount of lock-in. I didn't want a proprietary piece of technology that would make it difficult for us to migrate away from. And Ivan has committed to not doing that with inkless and diskless Kafka. I think that's huge, and it's time for the Kafka community to have this technology. So that is that was top of my list. And then in terms of why object storage for our workload, and every workload's different, right? I think it's important to step back and look at things holistically and understand if this technology is right. But for us, I looked at kind of the knobs and that are available to us and the trade-offs we can make. And we traded some latency for much more reliability. And I look at the properties of diskless Kafka, and I'm happy with what I see. I kind of like that the brokers are effectively stateless in a way. The state is often object storage. Replication is handled by the object storage layer. So that's a whole set of problems gone, right? And that's really nice. And then, the little bit of latency that we've added is really not that bad of a trade-off for our platform. We're talking you know, 500 milliseconds to maybe a second, and we can deal with that in exchange for not having to worry about data replication and disks and all of these other things that make operating a normal event streaming system, you know, quite difficult. So for us, it aligned perfectly with our needs, and we were able to fit our needs into the trade-offs, and it's worked out great. So I think that's kind of why it was a good fit for us, and I think that, you know, it could be a good fit for many use cases that I've worked on in the past, and you know, I'm happy to see it coming to fruition.
That's really cool, and I'm really glad that like the community is such a big part there. And I think that's something that, particularly last week at Current when we were interviewing people there, um, it's a really common thread, right? Of like the best technical solutions out there are the ones with people behind them that you can go and talk to and you can build with. Like, it's really nice to hear that echoed again here. One thing I was curious about as well is obviously you guys are using Diskless Kafka, but do you still have any workloads in parallel that you're keeping on classic Kafka for that, for those lower latencies, or are all of your workloads happy with that, 1 second max latency?
Yeah, it's a great question. At the moment, that's still something that we're evaluating. Um, to get into the weeds a little bit, the one case where we're somewhat latency sensitive is from one of the clouds we process data. We don't get full sort of config, uh, events that are enriched with full configuration of the resources that we're monitoring. So we get a change event, but then we have to go, kind of capture configuration in response to that. So we are a bit sensitive to the latency there. And that's maybe the one case where we want to keep the processing loop as short as possible. So we're considering classic topics for that, but we haven't committed to that yet. So even in that case, for our SLAs, we think 1 second is good enough, and it's it's better and it's faster than other solutions that are out there. And we're already looking at 3 to 5 seconds of latency built in from the changes applied on the hyperscaler to we get the event. So like, what's 1 more second? We're processing it as fast as we can, but we're already 3 seconds behind. Well, okay, what's a little bit more time there?
That makes a lot of sense. Yeah, I think this is something we see a lot where, as an industry within streaming, it's very tempting to chase real time and sub-second. But if your downstream producers aren't anything like that those kind of latencies, then yeah, it's kind of a moot point.
Exactly.
One thing that I was also interested to unpack a bit is obviously, this is quite the journey, like MSK to NATS to Diskless Kafka. And there's a lot of, like Kafka there and Kafka-like architectures and use cases, but those migrations still take time, right? And with this most recent migration from NATS to Diskless Kafka, and specifically to Ivan Inklis, how was that for you guys? What was the kind of operational cost of making that change?
Yeah, I'll say it was better than we expected. I think relative to the first time around, we have a lot more code this time and a lot more systems, and it's a bit more intertwined, and it's more sophisticated. So it did take longer, but in terms of writing the code, that's always the easy part. I think anybody can sit down for an afternoon and bang out some code. I think that's that was never going to be the expensive part for us. It's been sort of the coordination of, okay, we have to turn this system off and turn this system on and not lose any data in between, and in cases where we don't want to double, triple process something, now we have to be careful, because if we have 2 systems running at the same time, okay, how do we drain this side and turn on this side and make sure that everything is operating smoothly. So a big part of the cost was kind of upfront thinking about, okay, what's our strategy? How are we going to do this? And in what order? And what system are we going to migrate first? And how do we find the thing with as few dependencies as possible? Okay. And then just sequencing it out and thinking about, okay, we can move this, and then once those are moved, we can move this system, etc. Right? So we spent some time. That was probably a few weeks of effort to sit down and think hard about and do an inventory of everything that we have, and try to map the dependencies. And writing the code, as I said, was fairly quick. we probably spent a few weeks just getting together, handful of patterns that we need for our systems and kind of putting those into libraries and making it so that it would be easy to sort of apply those those new patterns to all of our various applications. So that was pretty quick. And then the migration has been slower, primarily because we have other things that we're working on in parallel, right? But the mechanics of it are fairly straightforward. We can migrate an application in a day or a couple of days if we need to, and we can carve out the time and be focused on it. But it all comes down to how much capacity you want to allocate to it. And we did the math and thought about it, and we're happy with how long it's taken and kind of the level of effort. But it really just comes down to understanding what you have and just marshaling the resources to get that done.
I really like that. Putting the emphasis on, like we had to take the time to think about making this decision as part of your migration costs. Because I think quite often things can be framed as like, oh, we made this quick switch to this. And it's like, taking the time to be like, is this the right thing to do before you start undertaking these like big changes is like super important. Certainly, I always appreciated that back when I was in platform of like, yes, we're migrating from A to B, but we've really, really done our work on B to know that this is a good choice, is what you want to hear, rather than like, oh, we've migrated from A to B. Could we go back to A 6 months later?
Yeah, that's never a fun migration pattern. And it applies to the whole stack, right? Obviously, we have the core technology, but for us, a big concern of mine going into this was, well, what's the state of the library ecosystem now? It's been a few years. Okay, we like this one. Okay, let's test it and make sure that we're still happy with all of the properties. Okay, migrating to Ivan service, monitoring it is different from our previous solutions, right? Okay, are we happy with how we're going to get observability data out of this? Yes. Okay. We have a solution for that. Understanding all of those moving parts, it really does take, some time to get your head around it and know that you have answers, because you don't want to be halfway through and have a critical system, migrate it, and then realize you have no visibility into it, or the library you've chosen is unmaintained and you need to migrate and you're already, your code's already in flux and it would be a mess. So yeah, being organized, I think was the key there.
I've had my fun with unmaintained Terraform providers before and running into those in prod. It's always an interesting conversation. Coming right back to the beginning of our conversation when we were talking about MSK, I remember you talking about like, opening up your AWS console and looking at the bill awaiting you for your like MSK spend. Now that you've gone through these various iterations of your streaming architecture, are there any particular like savings or line items that have disappeared that you're particularly glad to see?
I mean, pardon me. I love to see how much lower our EC2 and EBS. Sorry, I've revealed our provider of choice, but I like to see how much lower those costs are. Obviously, we're still running some servers to power, Kafka, but the capacity that we've deployed to satisfy the same workload is actually quite a bit smaller. I'm really impressed, especially going from something like NATS, which purports to be pretty lightweight and it's not JVM based, to now we're on Kafka again. The numbers are so much lower. Obviously, there's been a bit of an uptick in S3 costs, but those are substantially lower than our costs we were spending on hot storage and just servers that are running and trying to churn through and keep data replicated. So that's been a stark change. The other part, which was I guess I knew, but it wasn't really apparent to me until I was looking at the numbers, was just bandwidth cost. Here we have on the legacy side, we've got a system that is accepting data and replicating it across a cluster of nodes. So not only do we pay for bandwidth from getting the data into our system, and we're paying for load balancers and then that initial bandwidth charge to get it to the NATS instance, but then we have to pay a bunch of other times for it to be replicated all around, and then we have to pay for it to be consumed as well. And seeing those numbers go down was quite satisfying, because bandwidth in the cloud is quite expensive and it sneaks up on you. So seeing that go away and be replaced with smaller S3 costs is quite satisfying, especially when you combine it with some of the optimizations you can do with VPC endpoints and things like that. It's quite a bit more efficient to be consuming that data in batches out of S3 as opposed to message by message that's being replicated and across multiple AZs and regions and stuff. It's quite a savings for us.
It's really nice to hear, and I think we've certainly seen a lot of ink spilled on the exact amount of cross AZ data transfer or egress costs make up of an overall deployment or an architecture. But I think whatever number you pin on that, it is, it's good to see that it does come down with these new, whether it's Diskless or any kind of Diskless kind of Kafka model, these new sort of cloud native architectures that really reduce some of those unnecessary hops and transfers.
Absolutely, yeah, and I mean, surprised this is the first time you've used the phrase cloud native. I don't think I've used it yet either, but it really is, in my opinion, a nice optimization that really fits the technology into the primitives that we have available to us. So it's nice to be able to take advantage of object storage and get the benefit of that while still kind of writing our code in the same way and not having to sort of infect our code with those implementation details. So it's really been nice from that perspective as well.
Super cool. So it's been a real treat talking to you today. I think it's kind of rare to get this full view of how these kind of decisions get made at organizational scale. So I really appreciate you taking the time to speak to us today. One final question I have for you, which would be, we've heard today a lot about your experience with, designing your streaming architecture and thinking about different choices you need to make. What advice would you give to other technical leaders who are mulling these kind of decisions after your experiences migrating between these different solutions and ending up on Kafka?
Oh yeah, great question. Probably a few things. So we mentioned earlier, be organized. I think understanding your problems and what trade-offs and knobs you have available to you, hugely important. If you're going to migrate, or even if you're just looking to choose a solution and you haven't, you're not migrating from anything to something else, you're just looking to build, think hard about those and get a sense for, what systems need to exist and how they're going to interact. I think that's important. Understanding your costs. And, for us with the prior streaming systems, there are a lot of hidden costs in there as well. So, the bandwidth is one that, kind of hides among all the other costs. And, it's hard to really break that down into numbers you can understand. So getting a sense for how your data is going to move through the system is hugely important. That's probably my biggest thing, is just be organized and approach it with an open mind and try to ask those questions so that you can really get to a full understanding of what your needs are. From there, I would say be open-minded. Don't be afraid to deploy some technology and get a sense for how it works. I think there's always a lot of paralysis in the industry around, we need to talk about it forever and make the right decision and really stress. I would encourage, just deploy it, try it out, see, get a sense for what it's actually like to operate it, because you never really know until you've put it in prod. And it's easy to sit around and talk in terms of theoreticals, but turn it on, find a use case that you can, use to kick the tires of it and see how it behaves and see what you like and what you don't like, and, use that and feed that into your process, because I think that's hugely important and it's often overlooked in a lot of engineering teams.
So be organized, keep an open mind, ask questions, and get out there and experiment in the real world. I think that sounds like some solid advice.
Well, I hope it helps somebody.
I'm sure it will. Well, thank you again for coming on and sharing your experiences today, Kyle. I really appreciate that.
Of course, yeah. Thank you for having me. This is great.
It's been a pleasure. And thank you to everyone watching along at home. That is a wrap on season 1 of Get Kafka-Nated with our 10th episode. So thank you to everyone who's joined us for all 10. We have loads in store for the next 20 episodes for season 2, and we have a huge raft of interviews coming from current last week once we can get them edited and uploaded. So watch this space because there's lots more to come. Thanks everyone for listening.